This is day 48, the final day of my 2022 6-mark challenge for the AQA GCSE Science exams. Each day for the last 8 weeks, Monday to Saturday, I've posted a new example of a 6-mark question for you to use as part of your revision for these exams. There's a link in the description below to all of the questions that we've covered and also a playlist with all of the videos in the series. If you've made it this far, then hopefully by now you've got the idea that these 6-mark extended response questions are not essay questions. There aren't any marks at all in GCSE Science for writing in paragraphs or even in full sentences, and so I would really encourage you to answer these questions in the form of bullet points, because this is going to stop you from waffling and it's actually going to make it easier for your examiner to follow what you've written and give you the full number of marks. If you haven't done so already, pause the video now and give yourself 6 minutes to answer this 6-mark question. This question about these two different models that have been used for the atom could come up as either part of GCSE Chemistry or GCSE Physics because it's common content between the two papers. Now, if I were answering this question, I'd want to start off by establishing exactly what the plum pudding model is, and notably the fact that it contains the mass and the charge equally distributed throughout the atom. And this is important because the reason that the model was discarded was because it was shown that these things were not true. So in order to show that this was not true, Rutherford and his students Geiger and Marston did the alpha scattering experiment. And you might also want to describe what this is. So this idea that they took these alpha particles or helium nuclei and they fired them at a very, very thin sheet of gold foil to see what happened. Well, of course, the first thing that they discovered was that the vast majority of those alpha particles went straight through. And this was important because this was evidence that most of the atom was empty space. Now you'll see there that I've underlined the word most. It's really important that this is the majority of them. It's not just quite a few or some, it's actually the vast majority because the vast majority of the atom is made up of empty space. But not all of the alpha particles went through. Some of them were deflected, and they were deflected by really big angles and quite strongly. And this is important for a couple of reasons. Firstly, because it tells us that the mass is concentrated right in the centre of that atom, what we now call the nucleus, but also it tells us that the nucleus is positively charged, because we know already that the alpha particle is positively charged. So the fact that it's being repelled by something tells us that because opposites attract and like charges repel each other, that the nucleus must also be positively charged. As you'll know by now if you've been watching the full 6-mark challenge series, most of these 6-mark questions are level marked, and so that means you have to hit certain criteria in order to move up each level. It's not just the case that you can say 6 things that would be worth 1 mark each and get all 6 marks. So to begin with, there are some things that they will give you some credit for that aren't necessarily absolutely vital. So the first thing is this idea about the plum pudding model having equally spread mass and charge. It's a really important point and you can have a mark for each of those because if it weren't true, then you couldn't use the alpha scattering experiment in order to disprove the model. But at the same time, the question hasn't actually asked you to describe the model. So if you've missed it out, it is still possible to get 6 marks. The next thing that you're going to receive credit for, and this you do have to have included, is something about the experimental work. So you can have a mark if you've named it as the alpha scattering experiment, you can have a mark if you've described that alpha particles were fired at gold foil, and you are going to need at least one of those in order to get your 6 marks, because otherwise you haven't described the experiment. Then we need to think about the actual evidence, what they found, what they saw, their observations. And here's where it's really important that you're linking these ideas together. So the particles passing through the gold foil needs to be linked together with the fact that that is evidence for the atom having empty space. It's not evidence for the existence of the nucleus, it's evidence for the existence of gaps. So that's one linked pair. Then the small number of particles being strongly deflected, there's kind of 2 linked pairs here. So you could link that together with the mass being concentrated. You could also link it together with the mass being positively charged. In order to get 6 marks, you're going to need to have either named the alpha scattering experiment or described what it is, and you're going to have needed to have included 2 linked pairs. So probably you've talked about the particles going straight through and said that's evidence for this empty space, and then the particles being bounced off, and you've either gone for the mass being concentrated in the nucleus or the nucleus being positively charged, but you don't need both of those last 2 if you've got the bit about empty space and things passing straight through. So you need 2 linked statements and either naming alpha scattering or describing it. in order to get your 6 marks. So after 48 days and 48 videos, that is it for the 2022 6-mark challenge for AQA GCSE Science. I hope that you found it really useful, and thank you so much for watching. If you have found it useful, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.